if this particular event is binomial or not. And I don't know why I said this was to check your understanding, because it's not. It's actually an alternate example. So, letter B, I should say, not C, because we don't want to neglect B. Hey, what happens if we were to observe the next 100 cars that go by? And let a random variable C equal the color. Alright? Is the random variable C doesn't have a binomial distribution? Does the random variable C have a binomial distribution? That's what we want to know. What do you think? Okay, let's check our bins. Alright? Yeah, so B.
Check your bins before your record bins.
Right? Yeah.
Is it why?
Yeah, is it?
Yes.
Is it?
Wait, no.
Either success, is this, does this?
No. Because it's not yes or no, it's multiple choice, like red, green, blue.
Yeah, it's just A, red, blue, green.
It's not yes or no.
Fawn, is that a color? Chiffon? No, that's a type of text. Huh? Okay. MK? Okay, that's right. Thank you. All right. So, no. It's not binomial. It's not binomial. It's binary. So because we could have what? Red,
Green,
blue,
green,
green,
silver,
fuchsia,
dark green, turquoise,
taupe. Lately there have been a few taupe cars around.
turquoise,
I kind of like that color. How do I think it's awful? Like the four-wheel drive colors that are like the color of dirt already.
I like that one girl.
I like that. All right. Anyhow, sorry, we got sidetracked. All right. Since we're doing this, let's actually go through it. Is one event independent of the other? If I see a red car, does that affect the probability that the next car is blue?
No.
No. So they are indeed independent. They are independent. N stands for number. So are there a fixed number of trials?
Yes.
Yes.
100 trials.
So there are indeed a fixed number of trials. But since it failed one of these, right? It's not binomial at all. But we should do this just to success. All right. So is it clear what a success or a failure is?
Yes.
Sorry, and is the probability of success or failure the same for each trial?
Yeah, well, we don't have to define success.
Yeah, success really hasn't been defined, so no. Right? We don't. Yeah. Go define success. All right, well that was fun. Let's move right along. So, let's do a definition and then an example. Here we go, the binomial coefficient. So, we have this thing called the binomial coefficient. Binomial coefficient. It is very, 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 very useful. And if you can use it well, you will look very smart. If the situation where you can use it comes up, and you can use it, you look smarter than everybody. It's very cool. Okay, what it is the number of ways of arranging k successes. K successes among n observations. Okay? And it looks like this. So nk. In your calculator, it looks like, so for your calculator, it's n, my bad, not that n, it's a lowercase n. It's NCR, NCK. It's NCR. All right. So you have, I've heard, I had a professor that used to say, and this is the way I remember it, N choose K. N choose K. You have N observations, K successes. So you're going to have, like he would say N choose K. That's the way I remember it. And he was a real smart guy. So anyhow, the formula for that is N factorial over K factorial times N minus K factorial. Cool thing is you can just put this in your calculator and it'll spit out an answer. But I will do one calculation longhand so that we can see exactly what it is. All right? Alright, so just real quick, let's go ahead and calculate something simple. Let's do 5, choose 2. So why would you do something like this? Imagine that you had 5 numbers, and you wanted to know how many ways you could arrange them in two, how many ways you could arrange them so that there are 2 specific successes. Yeah, I've come up with a more concrete definition once we do the calculation. All right. So, okay. So n factorial. So remember, this is n. So 5 is n. K is 2. N factorial is 5. So anyways, let's actually look real quick. What is 5 factorial? It's 5 times 4 times 3 times 2 times 1. That's what 5 factorial is. If you are unfamiliar with what a factorial is, you should look because you should know this. You need to know. Alright, so that's what 5 factorial is. It's 5! Oh no. 5. Alright, so this is 5 times 4 times 3 times 2 times 1. Here. Thanks. And then 2 factorial is going to be 2 times 1. And I'm multiplying that by n minus k factorial, so that's 3 factorial, which is 3 times 2 times 1. And hey, I mean, you could do it like that, or you could say, hey, that's 1, and that's 1, and of course that's 1. So that's just cool. All right, so we did that calculation. And now let's go ahead and find this on our calculator. All right, so let's use the calculator. So if we want to have our calculator do that, because if you have a large number, right? If you had n equal to 100 and k equal to 50, you would have a lot of calculating to do. And so your calculator will do that for you. You will go to Math, and you'll go to Probability, and you'll have your NCR. And then you would put a 5 there, and a 2 there. On an 83, it's going to look like this. You would put so for an 83 Ti, of course. You're going to hit 5, and then you'll go to a probability, and you'll have the command that says NCR, and then you'll hit 2, and then hit Enter. So you'll follow the same commands, but you have to put the number in front, and then you'll put n in front and k at the end. All right. So for all your calculating needs, all right. So let's go ahead and apply this, or let's actually first get another formula in there. So. And then we'll find the application. Okay. So our binomial probability formula. Prob. Looks like this. We have the probability of x equals k. So k successes, right, is going to be n k over your probability of k occurring to the kth power times 1 minus that probability to the n minus k power. That too. Katy Perry as well. Because sometimes I actually do feel like a plastic bag. Yeah. Yeah. I feel like that very often. I know. I think that's just part of being human. All right. So we're looking for. So what? So if we define this in there, n is our number of trials. Wow. I wanted to write an F and a T at the same time because they came right after each other.
Me, whenever I write on the multiple choice
Like, which one? No, it's wrong. It's wrong.
What?
Okay. N is our number of trials. P is the probability of success on each trial. And then K, we'll be looking at the kth trial, right? So we're looking at, so K is saying, hey, we want to know the probability of success for our kth trial. That's what we'll do. So for instance, let's do an example. Yay. This formula is included on your AP formula sheet as well. And I need to actually... All right, so here we go. Let's do an example. Hey, the probability of rolling doubles when you roll 2 dice. Is 1/6, okay? Suppose you roll the dice 4 times. Hoping to roll doubles. A. What is the probability of rolling doubles twice in 4 attempts? Okay, so we're gonna find what the probability is of rolling doubles twice in 4 attempts. All right, so let's we have some variables that we need to define. P 1/6. I guess we'll just leave it as a fraction. All right. And our number of trials. 1. Oh. What in the world was that? That was not your back.
Got him.
And then K must be 2, right? So that's the only number we got. Alright. So then we're looking at the probability x equals k. And we're going to fill that into our handy dandy formula. And we're going to find it two different ways. We're going to do it longhand, and we're going to use the calculator. And I need the formula. Okay. So nk and that was 1/6 formula to the kth power times 1 minus 1/6 to the 4 minus 2. Right. Calculate it. And it's weird. Whoops, my bad. I do that. I have a tendency to do that.
Oh, you squared.
Okay, so let's get this part. This is 4 times 3 times 2 times 1 over 2 times 1 times, it's n minus k. It's n minus k. So 2 times 1 again. That's 6, okay. And this is 136. And this is 5/6.
25.
So 25 over 36.
Yeah. Sweet.
Which is, and we said
So 6.
that and that. So we said this was 12. So this is 6.
So it's, yeah. It's
Times 136 times 25, 36.
It's 25 over 36.
Which is 150 over 36 squared.
Yeah.
And we're going to probably come up with an approximation, really. I don't imagine we wouldn't wind up rounding. 150 divided by 36 squared is approximately 0.116. Awesome. We did some math. Looks pretty cool. Now that we've done it longhand, now we can let our calculator do this work for us. Because, good grief, you wouldn't want to have to do this every time.
Forget that.
Because you're going to do this a lot of times. So let's go ahead and let our calculator do the work for us. So, in this case, now we're going to look at a distribution. So we're going to go to stat. My bad, we want distribution. Sorry, second bars is distribution. Now we're going to look for binomial PDX. There you are. So it asks for n, p, and k, right? And n was 4, p was 1/6, and k was 2, right?
Enter.
So if you have a TI-83, yeah, when you click binomial PDF, what it's going to do is going to bring this up, and you're going to have your parentheses, and you're going to have to fill in 4, comma 1/6, comma 2. And that's it. You just have to remember that it goes N, P, K, right? N, P, K. And we hit enter. And we got the same thing we calculated by hand. Look at us go.
Oh, look at us go.
Look at that. How amazing. All right. Moving right along. And on the AP Stat exam, the best answer is going to be to write that and then put it in your calculator. Okay? This formula is available to you. So the very best answer is to write that. You could actually say, I use my calculator, I use binomial PDF, where n was equal to 4, p was equal to 1/6, and k equals 2. And then, right, you need to definitely include this notation. I'm sorry, I should have said x equals k. I should have said x equals 2. Sorry. Which is what k is. It's more correct to actually say probability x equals 2. And it's defined as a binomial probability. Yay! Alright. And we don't have a CDF yet, so that's what I really want to get into. Alright, sorry. So continuing on with doubles, what if we wanted to know the probability that it occurs in... Oh, the book has a way cooler way of talking about this. It's pretty cool. So, let's look at a second example that it can occur. This is a good question. Should a player be surprised?
Very.
If he gets doubles more than twice in 4 attempts. Yeah, he or she, I should say.
Pretty surprised.
More than twice. In 4 attempts, right? Huh. Not doubles. Yahtzee, isn't Yahtzee 5 of a kind or something?
Yeah.
Alright. So, in other words, we are being asked to find the probability that our random variable x, which is binomially distributed, is greater than 2. Okay? So So more than 2, exactly, and not 2 or more, but exactly more than twice, right? So that's the probability that x is equal to 3 plus probability x equals 4, right? Because either one works. If it occurs 3 times or it occurs 4 times, you count that as a success. So then if we're going to put that into our formula, we will have that is going to be equal to 4, 3 times
1. Wait, but then probably again.
1/6 to the k power, which is 2, 3 times 1 minus 1/6 to the n minus k, 4 minus 3 plus.
Dang it, I do that a lot. Wait, but 4 3.
I keep doing that. I'm so used to, as a math teacher, I'm so used to writing fractions.
Isn't it 4 4 too?
And n is 4, k is 4.
Yeah.
Times 1 minus 1/6
2 0.
2 to 0. Yeah. That's 4 minus 4. All right, so we can just go ahead and put that into our calculator. We're going to do that by going to our distribution. We're going to go to binomial PDF. PDF rather.
That's like the first time ever teacher was so great at first. Okay.
So this probability seems very high, and that is because our calculator is finding actually the probability that x is less than 3. So in order to find the probability that x is greater than 3, we have to use the complement rule. So we go, and that is a more correct solution. So keep in mind, so first I'll put our result and we'll talk about what's going on with the calculator. 0.016. So obviously they would be surprised, right? So probability x is greater than 2.
I don't know what the hell I'm listening to right now. Yeah, just
and this is what is being calculated when you do binomial.